Hello and welcome to the Tech webinar. Instrumentation and Control Engineering of Sarnam College of Engineering welcomes you to the webinar on the topic Design of Automatic Irrigation System. To be presented by Jerry Smita Preeti Engineering of Pioneer IC. Before going to the webinar we have today, I have a couple of slides to go through. This is about myself. Myself, Gopalakrishnan. I am webinar coordinator for the day and I am Assistant Professor of Instrumentation and Control Engineering. And to the audience. During the webinar, you could type the questions in the question box provided below, and at the last, all questions will be answered. And we in the Department of IC have conducted different events. We have signed MOU with different companies, National Instrument, Yokogawa, and IIT Bombay. We have conducted various workshops related to Yendra, LabVIEW, and Yokogawa. We also provide students with various certification courses. The IIT Bombay spoken tutorial online courses, LabVIEW Cloud developer courses, etc. During the seminar, you could connect with us to the link which is provided to your mail. And after the webinar, you could find the webinar at the YouTube on the topic titled Design of Automatic Irrigation System. And about the today's webinar, which is to be presented by students of Instrumentation and Control Engineering. And the speakers are Jared Sumita, Preeti, and and they have also published paper on instrumentation design for load cell using LabVIEW, and which is presented at the international journal. And today's webinar is about design of automated irrigation system, which is to improve the technology of farmers and developing the overall agriculture system. And to the speakers.
Good morning, viewers. In this webinar, we are going to discuss about our final year project, Design of Automatic Irrigation System, done under the guidance of Mr. S. Ramachandran, Assistant Professor, Instrumentation and Control Engineering of Saranathan College of Engineering. This is the overview of this today's webinar session. First, history, introduction, objectives, need of the project, process flow diagram, and process explanation will be discussed by me. Next, construction and hardware components will be followed by Ms. Preeti. Modes of operation and conclusion will be followed by Ms. Ranjani. First, history. Cultivating the plant is both art and science. Performing the irrigation in proper timing is an important factor for efficient crop production. But practically, it is impossible for human beings to perform the irrigation process based on the requirement of plants manually. In ancient days, irrigation required too much of manual work. Advancement in science and technology has created a situation to automate the irrigation process as well. In greenhouse, watering was done individually for every plant, which was a time-consuming work. Nowadays, irrigation is performed through manually operated valves and sprayers, which even requires continuous examination of the plants by the farmers. Next, introduction. In our project, irrigation is made automated depending upon the moisture content of the soil. The moisture content is measured with the help of load cell. LabVIEW, short for Laboratory Virtual Instrumentation Engineers Workbench, is a platform which we have used to control the entire system. myRIO is a device used for data acquisition purpose, which interfaces the hardware components and the LabVIEW software. The main objective to do our project are to utilize the resources with respect to the environmental changes, to help the farmers in reducing their effort in growing plants. With the optimum usage of both water and fertilizer, the growth of the plants can be improved. To perform the irrigation process automatically, the farmers can utilize our system since the cost of the imported kit are much higher. The basic need of a project are, since the moisture content is directly sensed by the load cell to perform the irrigation process automatically, work of the farmer is made easy. Overusage of both water and fertilizer can be avoided, so the yield of the plant could be efficient and also the soil pollution could be avoided. Crop productivity is increased with optimal usage of water and fertilizer, and the system is also cost effective. This is the process flow diagram of our system. In greenhouse, a potted plant is taken as a sample. It is placed over the load cell. An instrumentation amplifier is used to amplify the output voltage of the load cell. The output of the instrumentation amplifier is taken to LabVIEW. A suitable program has been designed which generates the control signals to the hardware components used in the system. The image shows the real-time design of a system. Next, the hardware components will be explained by Ms. Preeti.
Good morning, viewers. Now, let's continue with hardware components. Hardware components used in the system are load cell, instrumentation amplifier, solenoid valve, DC motor, level switch, and DC pump. Load cell. A load cell is a force or weight measuring sensor. It creates an electrical signal based on the force being measured. It is adaptable for some special applications in automotive, aerospace, oil and gas, and many other industries. For our application, CZL 601 10 kg strain gauge type load cell is used. It consists of four strain gauges in Wheatstone bridge configuration. When weight is applied, the strain changes the electrical resistance of the gauges proportional to the load. In our application, load cell is employed to measure the moisture content of the soil present in the pot placed over the load cell. Depending upon the weight of the pot placed, voltage deflections occur. Obviously, the weight of the dry soil is always lesser than the weight of the wet soil. Based upon the weight of the wet soil and dry soil, the percentage of moisture is determined. Next, instrumentation amplifier. As mentioned earlier, an instrumentation amplifier is used to amplify the output signal from the load cell. INA 125P, a low power, high accuracy amplifier, is used for the purpose. The figure mentioned here is the circuit connection of load cell with instrumentation amplifier. Next, solenoid valve. Solenoid valve is an electromechanically operated valve. It is a combination of basic solenoid and mechanical valve. It basically consists of a coil, an iron plunger, and a spring. When the coil is energized, the resulting magnetic field pulls the plunger, which allows the water to flow from one end to the other end. Spring is used to return the plunger to its original position. In our application, solenoid valve is used to control the flow of water to the mixing tank. It is controlled by using simple on-off logic using LabVIEW. Here we have used a 24-volt solenoid valve with a relay circuit. Next, DC motor. A DC motor is an electrical machine which converts electrical energy into mechanical energy. In our application, DC motor is used to mix the fertilizer with water in a mixing tank. A rotating blade is connected to the shaft of the motor to perform the mixing process. It is controlled by simple on-off logic using LabVIEW. Next, Level switch. The level switch is used to detect the level of liquid in a tank. We have designed a circuit for level switch using NOT gate IC7404. It detects the level of water in the mixing tank for our project. Two wires are fixed at the certain level in the mixing tank to sense whether the water level is attained. As the water level is reached, the contact is made because of the conducting property of water and hence the output voltage is attained and it is generated to NI myRIO. Next, DC pump. DC pump is a device which consists of a moving part which is a spherical rotor. It is used to generate the flow from one point to another within a system. Here we have used the pump to energize the flow from mixing tank to every plant in the greenhouse. It is controlled by digital output through LabVIEW. Next, mode of operation will be continued by Ms. R. Ranjani.
Good morning, viewers. Let's continue with the modes of operation. We have implemented 4 modes of operation in our project. They are auto mode with fertilizer, auto mode without fertilizer, timer mode with fertilizer, and timer mode without fertilizer. First, auto mode with fertilizer. In this mode, the irrigation process is done by measuring the moisture content of the soil, and the plants are irrigated with both water and fertilizer. As mentioned earlier, load cell is used for measuring the moisture content of the soil in the potted plant. The output voltage from the load cell and instrumentation amplifier circuit is acquired with the help of myRIO. The pot with dry soil will be of lesser weight and the one with sufficient moisture content will be of more weight. So the difference between their weights is calculated and the percentage of moisture content is determined. When the percentage of moisture content is less than 30%, the irrigation process starts automatically and it is performed till the moisture content of the soil becomes 90%. When the percentage of moisture is less than 30%, the solenoid valve is made to turn on by giving a digital input through myRIO. Water from the water tank flows to the mixing tank when the solenoid valve is turned on. The mixing tank is provided with 2 level switches, upper level switch and lower level switch, to detect the level of liquid in the tank. The solenoid valve is kept on till the water in the mixing tank reaches the upper level. When the water reaches the upper level, the level switch generates an output voltage which is taken to LabVIEW through myRIO. The fertilizer required should be added at this stage. The motor operation gets started to mix the fertilizer with water. The mixing operation is made only for a specific period of time, say 15 seconds. After the mixing operation is over, the DC pump is made to operate. DC pump is used to equalize the flow of the water fertilizer mix to every plant in the greenhouse. When the DC pump operates, the level in the mixing tank gets reduced. When the level in the mixing tank goes below the lower level, the DC pump is turned off and again the solenoid valve is made to operate. The process is performed continuously in a cyclical manner till the moisture content reaches 90%. Once the moisture content reaches 90%, the process is stopped automatically. Next, we shall see auto mode without fertilizer. The next mode of operation is auto mode without fertilizer. This method is similar to that of auto mode except the fertilizer is not injected. As fertilizer is not injected, there is no need for performing the mixing operation. The load cell measures the percentage of moisture content, and when it is less than 30%, the irrigation process is started. The solenoid valve is made to turn on till the level in the mixing tank reaches the upper level. After reaching the upper level, instead of switching on the motor, the pump is switched on. The water from the mixing tank flows to the plants in the greenhouse as the pump is turned on. And when the lower level in the tank reaches, the solenoid valve is turned on. The process is repeated till the percentage of moisture content reaches 90%. Once it reaches 90%, the process is stopped automatically. Now we shall see the next mode, timer mode with fertilizer. In this mode of operation, the user is provided with the facility of specifying the time at which the irrigation process is to be performed. The users can provide initial and final time of the irrigation process. In LabVIEW, the initial time is compared with the system time, and when it equals, the irrigation process gets started. First, the solenoid valve turns on, which makes the water from the water tank flow to the mixing tank, and it is kept on till the level in the tank reaches the upper level. Once it reaches the upper level, the fertilizer should be added and the mixing operation is performed. Mixing is performed only for a specific period of time and it is completed, and when it is completed, the DC pump is made to turn on. The DC pump supplies the water fertilizer mix to the plants. The above process is repeated till the final time is reached. When the system time reaches the final time specified, the process stops automatically. Next, timer mode without fertilizer. This mode of operation is similar to that of the previous mode, but the mixing operation is not performed as fertilizer is not injected. As similar to the previous mode of operation, the initial and final time of the irrigation process is specified. When the initial time specified equals the system time, the process gets starts by switching on the solenoid valve. The solenoid valve is turned off when the level in the mixing tank reaches the upper level switch. As soon as the solenoid valve is turned off, DC pump is turned on, which supplies water from the mixing tank to the plants. The above process is repeated till the final time is reached. Interlocking is provided between auto mode and timer mode of operation. When the user has specified timer mode either with or without fertilizer, and when the percentage of moisture content is above 90, the process is made to stop automatically even though the final time has not yet reached. Now let's see the front panel of the VI. The front panel of VI is as shown in the image. The user can select the mode of operation with the help of the enum control provided. The initial and the final time is provided by the user, and the system time is displayed in terms of seconds, minutes, hour, day of month and year. The devices solenoid valve, motor and pump are displayed as LEDs to check its state from the system itself. The output voltage from the load cell is indicated as wet soil voltage. The percentage of moisture calculated has also been displayed. Conclusion. Thus, an automatic irrigation system has been designed with the help of LabVIEW as software tool and myRIO as hardware. The system serves to be a cost-effective, user-friendly, and gives good reliability. In an effective way, the water and fertilizer control for the plant's irrigation is provided. Productivity of crops is increased with optimal usage of fertilizer and water. The system has reduced the manual work of the farmers. The time duration of the irrigation and the mode of operation to be performed is user-defined, which increases the effectiveness of the system. The system also reduces the economic-wise cost to the automation in irrigation. Thank you.
Good presentation, and I appreciate the effort. And before going to the last slide, we have a couple of questions from the audience for the speakers. How did you amplify the current from myRIO to drive you?
We have used a motor driver circuit. A driver circuit is used to amplify the current from the myRIO. The current from myRIO will be only of 2 milliamps, which we have amplified using the driver circuit and we have given it to the motor.
And next, we have a question. How did you configure the limit switch?
The limit switch configuration is used upon a parallel plate capacitance principle. We have designed an electrical circuit based on this principle using NOT gate IC7404.
And we have another question from Chennai participant. How did you think this can be implemented in real time?
Sorry?
How did you think that this project can be implemented in real time? Excuse me? Yes, the participants are hearing you.
It is implemented by using load cell. We have used load cell for measuring the moisture content continuously.
Okay.
And we have used LabVIEW as a platform for programming and we have used myRIO hardware for interfacing.
Do you think the LabVIEW platform will be efficient?
Yes, of course.
Okay. And we have another question. Why don't you prefer moisture sensor?
Moisture sensors can be used, but the difficulties of using moisture sensor is to do automation, any direct measurement will not give effective and accurate output for geological and chemical process. The maintenance and handling procedure for moisture sensor will restrict the automation. So for continuous automation, we preferred indirect measurement using load cell.
And we have another question. How did you observe the plant characteristics past the water?
It it's with respect to the percentage of the moisture content present in the soil. When the plants are in dry condition, the percentage is taken as 30 percentage, and when it is full, it is taken as 90 percentage.
That was a wonderful presentation, and I appreciate your patience for giving the presentation and the patience for answering all the participants' questions. And I thank the viewers for listening to the particular webinar. And if you have any feedback, you could put up in the YouTube link, or else you could directly comments to my email ID, which is given in the PPT. And the Instrumentation and Control Engineering of Sarnath College of Engineering expresses its thanks to the viewers and audience who are with us through the webinar. And I once again appreciate the sincere efforts of the speakers.
Thank you.